In this concept video, we're going to be discussing some cofunction trig relationships, and we'll also hit some reciprocal trig function relationships. I want to give you an understanding of where these cofunction trig relationships come from. So I've set up a triangle just like the one in the last concept video, and instead of making theta some value, we're just going to keep it as theta. So we're going to make some generalizations here. If we look at sine, or sine of the angle, we know that the sine of the angle is the opposite, which in this case is 3.2 over the hypotenuse, which is 5.7. So there's our ratio. We could go ahead and type it in the calculator if we really wanted to and figure that out. However, we're going to look at this other angle over here. This other angle over here, you'll note that all three of these angles must add up to 180 degrees. And if we take away 90 from 180, we're left with 90 degrees. So the two angles that are unknown here, together they must be 90 degrees. If this angle is theta, the only value this angle could be would be 90 minus theta. If we added these two angles together, you would get 90 degrees. Let's think about this in terms of an actual number to help maybe solidify this concept in your mind. This angle's 90, let's call that 30. Then 90 minus 30 would be 60. So we'd have a 60, a 30, and a 90, and that would work. That's a special right triangle. It does work with other ones as well. If that angle was 10, this angle has to be 80 to make this work out to be a triangle. And you'll note that 90 minus 10 up here would be 80 degrees. So if we know this angle is theta, this angle must be 90 minus theta. Let's take a look at what happens when we view this triangle in terms of this angle. I want you to notice that if we take the cosine of that angle, whatever it is, we're not sure what it is, it's just 90 minus theta. That's equal to the adjacent, which is 3.2, over the hypotenuse, which is 5.7. Something interesting happens here, and that's when we have sine and cosine. If we're looking at theta and the other angle, their ratios are actually the exact same thing. So one statement that we could make about the sine of theta and the cosine of 90 minus theta is that they're equal. So here's a relationship for you. Sine of theta is equal to the cosine of 90 minus theta. You can actually try this in your calculator. It might be useful to do that real quick. So let's make up a number. Let's do, 40 degrees. So let's make theta 40 degrees. So we're wondering, what is the sine of 40 degrees? And by the way, you should probably check your mode and make sure that you're in degree mode if that's what you're using, and we are. So here we are, we're in degree mode, so we're good to go. So the ratio of any right triangle, when we're looking at that 40 degree angle, the sine of any one of those, the ratio of the opposite to the hypotenuse, is going to be 0.6427, and then it keeps on going. What about the cosine of 90 minus that angle? So we can check the cosine of 50. Hey, take a look. It's exactly the same thing. That's what we see here. This is more generalized because we haven't actually put a value in here for theta, but this relationship does hold true, and it will hold true for any value of theta, not just 40 and 50, or 40 degrees for theta, and then 90 minus that would be 50 here. It'll work for anything. You could do sine of 20, and you could do the cosine of 90 minus that angle, which would be the cosine of 70, and it's going to be the same thing. The other functions work the same way, and I want to mention as well that you could have the cosine of theta, which would be, in this case, 4.8 over 5.7, and that would be the same as the sine of this angle, 4.8, which is opposite over hypotenuse over 5.7. So that ratio is the same, so it does work the other way. And all of the other cofunctions work like that. So we've got sine and cosine here, or sine and cosine I should say. And then we can also do secant and cosecant. So the co part is the important thing here. These are cofunction relationships. So the cosecant, the secant of theta will be equal to the cosecant of 90 minus theta. Or you could also do the cosecant of theta equals the secant of 90 minus theta. Tangent and cotangent work also. Those are cofunctions. You could also try this with the actual ratios and it's going to work out for you. And let's see, we've got cotangent of 90 minus theta, or sometimes you might have to use this one, or might be easier for you to use this one, the tangent of 90 minus theta. The reciprocal trig function relationships are a touch different, and we've hit on them a little bit already. And I want you to think about when we discussed the combinations and permutations, and you'll notice that the sine of an angle is opposite over hypotenuse, and then the cosecant of that same angle is hypotenuse. It's defined to be the hypotenuse over the opposite side. If we took 1 divided by the opposite over the hypotenuse, we could rewrite this as a multiplication problem. We need to use the reciprocal of the bottom, and so that will be just hypotenuse over opposite. So if we want to find the sine of theta, and we know the cosecant of theta, we could write this relationship, that the sine of theta is equal to 1 over the cosecant of theta, or the other way around works as well. The cosecant of theta is equal to 1 over the sine of theta. Another good way to think about this is just using this relationship. So if you know the sine of theta is like 4 over 5, then the cosecant is just 5 over 4. You can also set it up like this, but sometimes it's easier to just use that relationship right here. I'll write the other ones for you. The cosine of theta is equal to 1 over the secant of theta, or the secant of theta, move this up a little bit here for you, the secant of theta is equal to 1 over the cosine of theta. Likewise, you can have the tangent of theta, and the relationship there is it's a reciprocal with the cotangent. Or we could do also the cotangent of theta is equal to 1 over the tangent of theta. So these are the ones you're going to want to remember right here. I have just a quick memory trick for you. I remember that the tangent and cotangent always go together. They're also cofunctions, but then they also are hooked up here in the reciprocal relationships. And then if you take a look at sine, the first letter is S, and its reciprocal trig function has a different first letter. So it's easy to say, it's easy to make the mistake of trying to say that like sine is 1 over the secant because they have the same letter. You got to remember that it's a different letter. It works for the cosine. So cosine starts with a C. Its reciprocal trig function has a different letter. It starts with an S.